Okay, Honors Algebra 1. This is my last video I'm making before spring break. So I'm hopefully going to try and keep this short. We're going to start we'll probably do this over a couple lessons, converting between quadratic forms. And this one is taking place on 3/20/20. Okay. Alright, so we know there's three quadratic forms. You got vertex form, you got standard form, and you have factored form. Okay. And we should be able to graph at this point between all these forms. You should be able to graph from standard form, you should be able to graph from factored, and you should be able to graph from vertex form. Another good thing to know about quadratics is being able to convert between vertex form and standard form, and between each form, going from one form to the other, because each form tells us different bits of information. Okay. So the first conversion we're going to do is we're going to go from vertex to standard. Okay, now remember, vertex form is y equals a times x minus h squared plus k. And we need to we're going to convert it to ax squared plus bx plus c. All right. Best way to do is just do an example. Let's get a vertex form equation here. We're going to do, let's see, y equals 2 times x minus 2 squared minus 3. Okay. Now, just looking at this, you should be able to identify the vertex. The vertex is going to be 2, negative 3, but we don't really care about that right now. We're just going to try and convert it. Okay. So again, vertex form is good for finding the vertex. Axis symmetry, those are easy. All right, to convert it to standard form, the first thing you want to do is expand it. Okay. Now what that means is we're just going to, instead of having x minus 2 squared, we're going to write it as x minus 2 times x minus 2. And then don't forget the minus 3 at the end. The second thing you're going to want to do is to FOIL. Okay. So that's going to be first, outside, inside, last on the binomial times the binomial. Okay. 2 stays the same. First, outside, inside, last. First is x times x squared. Outside, x times negative 2, negative 2x. Negative 2 times x, negative 2x inside. And last, negative 2 times negative 2 is positive 4. Okay. Don't forget the minus 3 at the end. Okay. Combine like terms is kind of the same step. Okay, now again, most of you could do this skipping the writing it out part, but I'll write it all out for the first time. So it's going to be 2 on the outside still. The only thing we combine is the negative 2x, negative 2x. X squared. It's going to be minus 4x plus 4. Minus 3. All right. Your next instinct is probably correct. It's going to be to distribute. We have that 2 out front of the trinomial. So step 3 will be distribute. So we'll take the 2 and we're going to distribute it into everything, but not to the 3 at the end. So it'll give us 2x squared. 2 times negative 4, negative 8x. 2 times positive 4 is plus 8. and then you still have that minus 3 untouched. And then the last step, combine like terms, CLT, combine the 8 minus 3 at the end. So our final standard form, or what should be in standard form, is 2x squared minus 8x plus 5. Okay. And what can you tell real quick from standard form? Well, you know the y-intercept right away. Okay. We already knew the vertex and the axis symmetry from vertex form, but now we know the intercept, y-intercept. All right, so that is vertex to standard form. Expand, FOIL, combine like terms. Again, the FOIL, combine like terms, you could probably do that all in one step in your head. Most of you are pretty good at foiling at this point. So I can combine that to one. Expand, FOIL, distribute, combine like terms. All right, so that's version 1, converting. We're just going to go into 2, which is going to be factored form to standard form. Factored form to standard form. Okay, so factored form, remember, tells us the intercepts right away. Okay, if you're in factored form, you're going to know that x intercepts immediately. Okay. Recall factored form, y equals a times x minus p times x minus q. And standard form, we just did ax squared plus bx plus c. Now again, I pointed this out a couple times. The a value is in every single problem, or every single form. The a value in vertex form on the first problem was 2. The a value in standard form of the first problem was also 2. So that's one way to check yourself. If the a value changes, you did something wrong in that process. All right, so let's get a factored form equation. Let's do y equals -3 times x minus 6 times x plus 1. Now right away you should ask yourself, what's the x-intercepts here? The x-intercepts are going to be +6 and -1. We also know this parabola is going to open down because the a value is negative. Now again, that -3 should be in our final answer. This one's very similar to vertex to standard, okay, because standard form is just the standard quadratic form. So you need to simplify everything you can. All right, so your first instinct in this is probably correct again, which should be to FOIL. FOIL the two binomials. Leave everything else the same. So we've got y equals -3. First outside, inside last. First, x squared outside is 1x. Inside is -6x. Last is -6. Okay. Combine like terms. The only thing we combine is 1x and -6, the inside and outside. Again, most of you can probably skip that first step and just do it in your head. All right, and then our final step here, again, this one's easier than vertex to standard, is to just distribute. Okay, distribute the -3 into everything. So our final standard form is going to be y equals -3x. -3 times -5x is +15x. That's -3x squared. My bad. And then -3 times -6 is +18. So once again, your a values match from the original problem to your ending problem. We knew the x-intercepts from factored form. We now know the y-intercept is going to be the c value, 18. And you can find the axis of symmetry from either form using the formulas from factored form or the formulas from standard form. I think that might be it. Quick lesson on a Friday. Check classrooms. There's going to be a final exit project for the week before you can go on spring break. And enjoy your week off.